Today's 25th of September. Now, last time we were talking about markups, and finally, again, after much effort, I think I managed to put some problems on the website. There's not many, and it was something of an ordeal. And I probably, racked up a few of those demerit points, that because you said stuff you shouldn't have. But I persevered. I finally got it figured out. There's something I want to point out to you here. And then Gretchen said she wanted to look at a problem. We started off talking about markups and markdowns, and I think I mentioned this, but I didn't talk about it very much. And when I was looking at the problems, it occurred to me that maybe I should mention this a little bit more. But your basic relationship here is your selling price equals what it cost you plus the markup. Now, you can write it like that, plus the dollar markup, and all of these things will be in dollars. So you're adding dollars to dollars, and that equals dollars. And if you look on that handout I gave you, it's also 226 and 227 in your book. It mentions this, and then the book replaces that with some sort of percentages. Percentages of cost or selling price. So you're still dealing with dollars and dollars, but there are some of the problems that are, I think I might have assigned one or two, that actually ask you to find the dollar markup. And it's nothing tricky, it's just that right there, what I've just showed you. So if you bought something for $10 and you wanted to mark it up, you wanted to sell it for $15, your dollar markup's $5. Now, depending on what you're doing, you might want to convert that into a percentage. But strictly a dollar markup is just a dollar figure. And it's pretty easy calculated. You either add something or subtract something. So don't get confused when it says dollar markup. It's just a dollar figure. Now, also in this chapter 8, there's a section here on pricing perishable items and break-even analysis. The perishable items aren't that tricky. I do think I'm going to put them off till Thursday, and maybe hopefully I'll get a chance to work one or two of them out and kind of refresh my own memory. But they're pretty simple. The break-even thing, something about this book, I've never really got it to make sense to me, but I haven't given up yet. So hopefully I'll get a chance to look at that too. What I'm saying is, for the time being, let's go on to chapter 10. But we want to work. Which problem was you want to look at, Gretchen?
The first one, the easiest,
Was that?
selling price of lumber and
I was trying to remember what number that would be. Do you have a number in the book? Yeah, I know. See, that's the problem. Those numbers don't correspond to the numbers in the book. Well, they do when I'm looking at them, and then I think when I assign them, the number gets changed. I think. Details are still very sketchy about this. So it's the one with Walmart, or what is it?
Home Depot,
Yeah,
$4,000 percent markup.
Home Depot. Let's see if we can find that one. I know it's in here somewhere. Is this the selling price of lumber at $4,000? I think it's on page 229. It's 8-4 in your book. Now, what it is in the online homework, I don't know. So let's look at this. So I think it's 8-4. You're told that the selling price equals $4,000. I did turn it on, didn't I? Yeah, I did. And you're told also that the percent markup on cost is 30%. I turned these lights off up here now. I can't see my book myself. And we want to find C. Okay. So that's what you have to work with. Now let's back up a couple pages or two here and see if we can find
Like, has the 30% markup already been taken out of it?
no.
Making it 4,000?
No, that's how we got up to $4,000. See, the selling equals what you paid for it plus the markup. Now, in this case, we're told this, and we're told this as a percentage of cost, and the cost is what we're looking for. Okay? Now here's what I recommend. You got your book there in front of you. This is based on cost. You see there where it says percent markup on cost? So let's go back on page 226. You remember in that left-hand column, those first formulas there are based on cost. And then when you go over to page 227, those are the ones based on selling price. So that kind of gets you in the ballpark there. We're going to be on 226. So let's look at that left-hand column on page 226 and see if we can find ourselves a formula that will work for us. And we know S, we know the percent markup on cost. We're looking for cost. Ideally, we come up with a formula that's got cost on the left. So, and then selling price and percent markup on cost on the right. Look down that column there. Do you see anything that looks like it will work for us? What about the bottom left
The selling price
little block there?
divided by 1 plus percent markup on cost.
So the selling price divided by 1 plus percent markup on cost. Does everybody see where I found that? Very bottom left-hand corner on 226. Okay. In just a minute, I'll show you how they got this, just in case you're interested. So now let's plug in our numbers here. We know that, $4,000. And here we're going to have 1 plus this percent. Now, this 30% is what?
0.30.
Yeah. So we need to add those two together, don't we? Okay, so with the help of our calculator. $4,000 divided by 1.3 equals. I got $3,076.92. What'd y'all get? Good. I feel better if y'all get the same thing I do. Because I've been known to make a mistake. Of course, I just do that to keep y'all on your toes. Y'all believe that, don't you? Does that help, Eddie?
Yeah, I know what
Okay. Now, let me show you where this comes from. So, just so you don't think we're just making this stuff up. But let's start out with this. We know the selling price equals the cost plus the markup. And on a problem like this, we're told that the markup is a certain percentage, in this case 0.3, of the selling cost. So think about how I got that. So instead of M, now I have 0.3 times C. And I got that from the problem, actually. It says percent markup on cost is 30%. So instead of M, I write down 0.3C. Now, you remember back in the days when you were doing all this math and it was like, boy, when am I ever going to use that? Well, watch. I'm going to factor out a C. You remember factoring? Watch. This C times the 1 is that guy right there. And the C times the 0.03 is that guy right there. Okay, I pulled out a C. Okay? So now I've got this. Now recall, I'm actually trying to find, what was it, cost? So recall here, if I want to solve for C, well, first thing I'm going to do this. I just flipped them, didn't I? I wrote that over there and I wrote that over there. Okay, didn't change a thing, did I? Okay? I just flipped them around so they'd be in the right little form here. And now here's what I'm going to do. Divide each side by, okay? So now I've got C equals S divided by 1 plus 0.3. So that's where it comes from. That's how I got there. And it started out with this basic relationship right here. Your selling cost equals what you paid for it plus your markup. Okay? So these formulas you see here on page 226 and 7, they're all based on this. We just do a little math on them and get them in a form that makes it a little bit easier for us to work with. Now, see here, once they get rearranged and you know what's going on, you could use all these formulas and don't have to worry about where they came from. Okay, you don't have to worry about deriving them on your own. How's that? But that's where these formulas come from. They start out with something basic and just switch things around for particular problems. And at the end of these chapters, they kind of show you these formulas that So you don't have to remember every little thing. You can look it up. Okay? So that's where it comes from. I didn't make this up. Okie dokie. So Thursday, we'll look at a couple more things, hopefully, from chapter 8. But right now, let's go on to chapter 10. Oh, by the way, does anybody else want to look at anything in chapter 8? And I know you probably haven't had time to look at those few problems I put in Blackboard. Look at them between now and Thursday. If you have any problems, just let me know. We'll work them out. Okay? So let's go on ahead here to chapter 10. Chapter 10 is on simple interest. And
It may look simple to you.
well, the problem is, though, I don't know how much we actually use simple interest anymore. I guess you still pay simple interest on loans, I guess. We'll act like that's what you're going to use it for. Because if you put money in the bank, like a savings account, it's a different prospect. Now, here's what you need to remember. I equals PRT. You have your interest. And I always forget if that's PLE or PAL. I think it's PLE, isn't it? Nope, it's PAL. Principal rate time. Now we use this formula a lot, and just like these other formulas we've been looking at so far, you can rearrange that as you need to. Okay, you can do basic algebra on it, rearrange it as you need to. Now, the next thing here you need to remember is there's actually two ways of looking at the time. It's on page 267. So, it talks about method 1. The important thing here is exact interest. That just means there's 365 days in a year. Now, we all know that, don't we? You know, sometimes you think you know something, but then again you find out you don't. Because there's another method, and again, I'm not sure how much this is actually used, because my wife works at a bank and I ask her these questions and it's like, she didn't know anything about method 2. Method 2 is called ordinary interest, and for some reason, well, I know why. Years ago, banks come up with this. The assumption is, well, there's not really 365 days a year, there's only 360. And you look on page 267, right underneath where it introduces this ordinary interest, it points out this is called the banker's rule. So the bankers came up with this. It actually makes the interest a little bit higher. So this is one of those kind of things where you're paying them, so they're, by calculating it with 360 days in a year, it actually turns out to be higher.
Is that what you predict?
I guess it's whatever you can get away with.
My gosh, even more.
I guess I haven't really studied the history of this, but the invention of banking back in like the Middle Ages was a pretty big deal. So I guess we need banks, but sometimes it's frustrating. How many people watch Seinfeld? Boy, I never did really watch it that much. How about there's another TV show called Veep, I think, Veep. Any of y'all watch that?
What is it?
Veep. I'm gonna go off script here a minute because I just like to do things like this. And I got to think of her name. It seems like whenever I want to remember a name, I can't. And then the next time I run across somebody's name I can't remember, I'll remember. But this lady here, y'all ever seen her? Y'all seen her? Y'all recognize her? Her father was a banker worth billions of dollars.
Yeah, you can hit on his name.
Yes. And he died not long ago. So I'd like to copy this. Just copy this. Go up here. Yeah, there you go. I like to check out people's net worth. And I've actually seen bigger figures than this.
Jared Seinfeld worth $900.
Yeah, Seinfeld is just, it's amazing. Actually, I'm pretty sure she's worth more than this because I'm not sure they figured in what she's going to inherit from her father. Anyway, let's see. Here's a different one. They got her at $3 billion. This is figuring in her inheritance. Isn't that amazing? People you see on TV, and she is funny. I'll give her that. I just don't watch that many comedies. But her father was a banker. There's a lot of money in banking, apparently. Anyway, he died recently. Okay. All right. I think we're probably ready to work a problem or two here. There is another, well, there are some other little wrinkles in this chapter, but we'll worry about those in a minute. Let's go work some problems. Let's look at 275. If I can keep my book from falling on the floor. Let's see. How about this? Look at 10.2. We are given, the principal is $4,500. That's what we are borrowing. We're told the interest is 3%. Now we got to turn that into a what? A decimal. And we're told, by the way, that's R. T equals 6 months. Now, here's something you got to pay attention to. right up here I introduced this idea that if you're doing exact interest, there's 365 days in a year. Ordinary interest, there's 360 days in a year. If the time is given in months or years, you don't worry about that. You just make sure that you have the same units here, and I'll show you what I'm talking about. Now we're supposed to find the interest. Interest, I equals, remember PRT, so we're going to have $4,500 times what? 0.03 times time, which is 6 months divided by 12 months. So whatever unit I have here of time, I have to make sure I've got the same time on the bottom, so those two units cancel out. Okay, I can't put days on top and months on the bottom, or years on top and days on the bottom. I can't do that. I have to make sure I've got the same units. Okay, now the assumption here is this 3% is per year. You don't say that, does it?
6 months and the 12 months, and you cancel that out. And
Yeah, the months cancel out.
you have
You're
to-
still left with the 6 and the 12.
So are you reducing that fraction?
Yeah.
To the 1/2?
Yeah. Well, if you got the right kind of calculator, you can put it in like this. That's another reason to have this fancy calculator. But first thing, does everybody understand that this 3% is per year? Okay. So, and actually, you can look at this as months per year. Months per year. So you're actually looking at everything from the standpoint of a year. All right. In this case, if we kept it all year, we'd pay 3% of the 4,500. We don't keep it for 6 months. So, and Melissa's right. If you reduce 6 over 12, that's 0.5. So you keep it 6 months, you're only going to pay half of the 3% of the 4,500. Okay? So here's what I'm saying. Kind of convoluted that, didn't I? The interest per year is going to be 4,500 times 0.03 times 0.5. Does everybody see where the 0.5 came from? Now, if you're using a simple calculator, you're going to have to do that first. Okay? If you've got one of these calculators, we could put that whole thing in right there. And I'll show you. 4,500 times 0.03 times, watch this, parentheses, 6 divided by 12, enter. What'd y'all get?
$67.50.
Good. Now, how many people actually have the graphing calculators? About half of you. Do you see why I put this in parentheses?
Yeah, 'cause that has to be done first.
Well, I'm forcing it to do that first. The parentheses are saying we'll divide 6 by 12 and then multiply it by these other numbers. If you don't put those two in parentheses, you're not going to get the right answer. Okay, so just remember, you need to put those in parentheses. Okay, everybody okay so far? Now, there's another part to that question. Let me scroll up a little bit here. It wants to know the maturity value. Let me change back to red. I like red. Maturity value is the total you have to pay back. Okay? And, you know, the way these things work, you know, a lot of times you'll go to the bank and you'll say, I need $5,000 for 3 years. Well, 3 years is the term, and at the end of 3 years, they want their money. Okay? This loan has matured. That's why they call it maturity value. M equals the principal plus any interest that you owe. In this case, we borrowed $4,500. We just got through calculating the interest for 6 months at $6,750. So for this particular loan, the maturity value is $4,567.50. So that's an answer, and that's an answer. And get my calculator here, and I'll add that to it. Plus 4,500. All right, y'all okay with that? Wasn't too bad, was it? Let's work another one. While we're rolling on here. Let's see, how about, here you go. How about 610, or 10-6 rather. 10-6. And we're told here that we borrowed $1,200, that's the principal. P equals, I keep forgetting to put the letter down. I equals, wow, 12%. I don't know if I mentioned the fact that this book is in its like 12th edition, and if you figure the edition will last 2-3 years, you know, this book's like 25 years old at least, and a lot of the problems and examples I don't think make sense anymore, because we haven't paid 12% since, well, I don't know. Some of these payday loans get pretty expensive. Anyway, I fuss a lot about the numbers in the problems, and it's usually for the interest rate. I don't think a lot of them are realistic. Now, what do you see next there?
Date borrowed, date repaid.
So we have June what?
Basically 6 months, 2 days.
Oh, I got both of them wrong, didn't I?
July 7th.
Hang on. July 7th through January the 10th. Wonder what we're going to do with that. What? Well, we're going to deal with this as a number of days. Yeah. Remember I gave you this? You know, that ordeal, it took me 15 minutes to get this one day. We're going to use this a lot. So, now, here's the tricky part. The tricky part is this goes from 1 year to the next, doesn't it? Okay? Now, we could do this. We could figure out what day July the 7th is and subtract that. I guess we can do it both ways. Let's do that. Let's see. End of the year. I'm going to write it like this. End of the year, because you might want to do it this way. The end of the year is 365 days, isn't it? Okay? So, July 7th, let's look up and see what day of the year that is.
188.
188. Now let's subtract that. That's 7, and that'll make that a 5. That'll make that a 7 too on it. And then we borrowed that. Y'all get 177. Now that's the days the first year. And then how many days we have the second year? Well, that's pretty easy this time, isn't it? Because January the 10th is the 10th day. So days with the loan is 187. Okay? Now, is everybody okay so far? Now here's what we're going to do. P equals IRT. Now, did it say, what's the instructions? The instructions say ordinary interest. Ordinary interest means the assumption is there's only 360 days in a year. But you still use 365 when you're figuring out the number of days. The 360 will come in here in a minute. You still use exact days on this. And again, I don't know why we even fool with ordinary interest. So, I got that backwards, didn't I? Hope y'all didn't write that down. Interest equals PRT. So we're trying to calculate the interest here. Well, I'm just making all kinds of mistakes. So $1,200 times 0.12 times. Now, we have the loan for 187 days, and if we're doing ordinary interest, the assumption is there's 360 days. Okay? So, since I'm figuring days here, I had to use 360. Now, if it had said exact interest, I'd use 365. Okay? So I had to have days over days, so those cancel out. Okay? Now, if you're using like a non-graphic calculator, you're probably going to have to do that part first. So the interest equals, and since I've got a graphic calculator, I'm going to put it all in at once. $1,200 times 0.12 times the quantity, just like before, 187 divided by 360. Close that parentheses. And I got that. Let's see. Does it want maturity value? Yeah. What'd y'all get? $74.80. And maturity value equals P plus I, which is $1,200 plus $74.80. So that'll be $1,274.80. That's what you got to pay back. And I'll do that right here. Plus. Okay? So with a non-graphing calculator, you're going to have to do this first and write it down. Now be careful rounding off a lot of places here, because that's going to throw you off. I'd probably keep 2 or 3 decimal places for sure if I did this first. Do I see what I'm saying? Okay? Y'all okay with this so far? What was different about this one? Well, it had days.
Yeah.
Now this one had the further wrinkle that it spanned 2 years, didn't it? So we found how many days to the end of the year and then added the number of days in the next year to that. There's actually I consider it a simpler way. Okay? And I'm going to show you what this is. You can use either one. I don't care. So what I'm going to show you now is a different way of calculating the days we have the loan. Okay? Now, here's what I would do. Our dates of interest here are July, what is it? 7th, and January the 10th. So let's look these up. July the 7th we said was what day of the year? 188. And January the 10th was we're coming up a day off here. How do we do that? 187. Do 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 do. Oh, I got it. Add these up. And think about what I wrote there. So if you think about this,
We did not have one.
yeah, we did not have the loan. Okay, now I'm looking at this where I'm not even going to worry about spanning 2 years. I'm just going to say, well, let's see, July the 7th and January 10th or July the 7th, we did not have the loan. Okay, now, what if we do this? And I think you'll find that. So you see what I did? You can kind of look at this as I found the complement of the time, and that would be the period in a year that I didn't have the money, didn't have the loan. So once I get that number, and it's pretty easy to get that number, isn't it?
166.
Then I just subtract that from 365, and that's the days that are left. That's when I had the money. You can do it either way you want. I happen to think method 2 here is easier, but that's just me.
I got 167.
Yeah, 167.
What?
That's what you subtract 165.
Oh,
198 from 365.
let's see here. I was supposed to subtract, and I added. Watch. Right here, this should be a 7. Oh, what I was thinking. That's a 7. You're right. Watch. Subtract these 178, 178. That make it look gooder? Yeah, that makes it work. I added up there when I should have subtracted. Sometimes I get so busy talking, I don't keep up with what I actually did. So everybody see why I had to subtract? Makes sense when you think about it. This time of the day, I'm not sure how much thinking is going on. Sometimes my thinking is a thunk. You know, that dull thud sound that, Sorry about that. Good catch. You gotta watch me. Anyway, I think that's easier. You may or may not. It's up to you. Let's see here. Let's work a word problem. And a lot of these use this ordinary interest, and I don't know why. It drives me nuts. And I still say that's not what you run into in the real world. See, if you look at these problems, it's like assume ordinary interest, ordinary interest, ordinary interest. Well, let's just work one right here. Yeah, I want one that's exact.
10, 17.
10, 17. See, I try to not to work the odd ones though. Yeah, I saw that. And a lot of these will be like, oh, 1021 work it this way, 1022 work it the other way. And this is one of the more frustrating things about this book is its insistence on using 360 instead of 365. I just don't think most places do that anymore. Pretty much every one of us use ordinary interest. And there's no reason to. It's not any harder to do it exact than it is to do it with ordinary. It's just numbers you punch in a calculator. So I don't know what the deal is. Well, let's do this. If you look at 10.7, 10.8, 10.9, these says complete the following using exact interest. By the way, if you look on this page, which is my page 275, I think it's yours too, these problems here are really no different than the word problems on the next couple of 3 pages. It's just on this page they pick the numbers out for you. Okay, so it's the same type of problem. It's just one, when you get into the word problems, you've got to pick the numbers out yourself. So let's work one of these, and then we'll probably declare a victory. And move on. Let's see. Probably should get another slide here. So let's look at 10.8. Principal is what, 585, wasn't it?
Yeah.
R equals 9%, and that's 0.09. And our times are June 5th through December 15th. Okay? So I always put the last date on top. And now let's go to our chart here. December the 15th is what day of the year?
349.
Okay, so that's 349. And July the 5th is out there in the middle, ain't it? What'd y'all get?
It's June the 5th.
Oh, sorry. Got to get over one. 156. I should have been able to do that in my head. 'Cause there's 30 days in June.
93.
Yeah, subtract, not add like I did last time. The days with are 193. And remember, the instructions say exact. So the interest equals P times R multiplied by the time. So we have 585 times 0.09 times 193 days over 365 days. And of course the days cancel out. Interest equal. All right, did I set that up right? I think I did. Okay. $585 times 0.09 times the quantity 193 divided by 365 this time. So what'd y'all get? $27.84. Maturity value equals P plus I. So that's going to be 585 plus 27.84. That's the dollars. $612.84. Let me make a copy of this. Okay, everybody okay with that? So when you're reading these problems, pay attention to whether it says ordinary interest or exact interest. I prefer exact myself, but for some reason, like every problem you look at says ordinary. The other thing is make sure you get your time right. We worked a problem there that was in months. We also worked a couple problems in days. There's a couple problems in here, I think they're in years. So if it's a 3-year loan, over here at the time you're going to have 3 over 1. Okay? Or just times 3. So get your time right. Make note of whether it's ordinary interest or exact. If it asks for maturity value, you just add it up. Add the principal to the interest. Now, if you look at the top of page 276, there's some problems there where it's like they give you the interest and want to know what the time was. That to me, that's just silly. Because if you're going to go get a loan, you're going to know all those things. So I don't even look at those. Like 10, 10, 10, 11, 10, 12. 1013 we'll go into next time. The U.S. rules, partial payments. It's not that big a deal. So we'll do that next time, and hopefully we'll go back and look at a thing or two in Chapter 8. Alrighty? Hopefully I'm going to go home and say, boy, I need to put some homework on for the math class. We'll see if I can remember that. Alrighty? So, I'll see y'all Thursday.
be careful.